Okay, so hi everyone, my name is Jyoti Mishra, and my mentor was Dr. Clayton Riggins. And so together I studied the impact of racial disparities within neuroscience research. In today's presentation, I'm going to be going over introductions of who am I. I'm going to go over the disparities, and then I'm going to go over the specific devices within neuroscience that I studied that have shown and yielded results that are very prejudiced and racially biased. I'm going to connect them together, and I'm going to talk about possible solutions that we have and that are already readily available. And then we can conclude with any ending remarks. So starting off, so as I said, my name is Jyoti Mishra. I'm from South Riding, Virginia, which is like a suburb of DC. And some of my hobbies are like sports, cooking, and reading. And so moving on to research, why did I choose this topic? I have a really strong interest in ethics. I've wanted to go into medical malpractice law for a very long time. And I do have like a very strong STEM background. And so I decided to connect the two, specifically within neuroscience, because it's a very progressive field. So the purpose of my research is to disentangle phenotypic differences and racial biases within data collections, so its implications, origins, and remedial strategies. So the expectations and reality within research. So what is neuroscience research and why is it used and how is it implied? So what is it? It's a study of brain and cognitive function, and it advances the understanding of the body as a whole and how any impact on the brain can impact the body. However, in diagnosing and doing research, every single person's body is completely different, and including facial features, eye color, skin color, hair texture, everything as a whole. And so we know that each body is different. So this is where the research proposition comes in. We decide to research different demographics as they can have different responses to different diseases. This includes cerebral palsy, Parkinson's, epilepsy, which can be common in certain demographics, but not others. And so this holistic approach assists the brain. We can understand the brain and its cognitive functions and assist it if needed. So the only issue is that we're trying to create products that can be beneficial to everybody, not just one demographic. So the issue with this is that we have a history of racism within medicine, and this is prominent as people of color are excluded from data collection and data testing. And this is apparent through like the Tuskegee trials, where people were experimented on without their consent. And they were not told and they were not reported. So basically, African Americans were given syphilis and left to essentially rot in certain terms. And the data collection was rendered as unusable or bad data. And the vaccination that came from that data was used on only white people. So an entire demographic was completely excluded from syphilis, and this led to a lot of people passing away due to that. And then from that and experiments like those, we have machines that are based on phenotypic differences. And this can be concluded with things such as laser hair removal, where the laser hair removal will target melanin, like dark hair. But if you have dark skin and dark hair, it won't be able to tell the differences, and it'll essentially burn you if you have deeper skin tone. And then this is also stemming from implicit biases of workers, where they feel that it's only important to target one demographic that's being impacted by the research and not everyone as a whole. So where did this come into neuroscience? We talked about the origins. Let's talk about the neuroscience part. So there's two machines that are often used for diagnosing, very common within neuroscience, but they yield two different results depending on the color of your skin tone and the texture of your hair. So FNIRS, functional near-infrared spectroscopy, it's basically low levels of non-ionizing light, and it is used to record estimating oxygen levels and changes in oxygen levels. So basically what happens is that the light will penetrate through your hair and skin as the cap is placed over your head, and basically it'll record the oxygen levels within the brain. This is an issue with people with deeper skin tone because, as you can see where my mouse is pointing, the light is unable to penetrate through the hair and into the scalp, and therefore the oxygen recordings are often incorrect and inaccurate. So what happens is that this data becomes error-based, for lack of a better word. And the data from the white person, the person of lighter skin tone, it becomes accurate, it comes out decent, and therefore you have a demographic where is marginalized data versus real usable data. And then therefore it'll become, the medical outcome would be a lot better for diagnosing for the person of lighter skin tone. Similarly, we have EEGs. So these are electrodes that are placed onto the scalp, and they're used to measure brainwaves. And this, as you can see, this little girl has finer hair, and the electrodes are able to penetrate through her scalp. And this is often used to diagnose disorders such as cerebral palsy, epilepsy, and Tourette's even. So whenever there's a misdiagnosis, we can often risk the idea of possibly misdiagnosing them and mistaking a diagnosis for something it cannot be, which can be fatal. So since this person has finer hair, you can imagine that the brain waves would be a lot easier to render versus someone with thicker hair. Those electrodes would not be able to reach the scalp, and therefore it would cause a lot of issues in recording brain waves. So what is the correlation between data collection and unusable data? Well, there's a lot of prejudice with the machines that are being created, as I showed you. The machines that are being created are often categorized towards the Western demographic, people with finer hair, people with lighter skin tone. And this leads to exclusion within data collection within specifically neuroscience, which, as we have an understanding, can have severe consequences and liability, because if we have inaccurate data, it'll lead to inaccurate diagnosis, which means any machines created for the purpose of healing people or helping people with a certain disorder can be inaccurate and can only be targeted towards one demographic. For example, a little girl of African descent could have had cerebral palsy, and the EEG did not record the diagnosis accurately because the electrode on the scalp was not able to penetrate through. So whatever machines are given to her will not be accurate and helpful at all in any way, shape, or form. And this is shown by like the neural response of this visual right here. So anything that's placed onto the scalp or hand, it's rendered unusable. So this is kind of wasting our time, and it's not allowing us to create any sort of beneficial medicine towards this entire population of people. And this is not just for African Americans, it's also for anyone with curly hair, anyone with deeper skin tone. So this could be South Asian, Middle Eastern, Eastern European even. So all these people are being cut out essentially from the neuroscience community. So we do have some remedial solutions and possible solutions with this, however, but it's only for EEGs as of right now. What is happening is that for the EEGs, we're using cornrow as a method to expose the scalp for people with coarse and curly hair, and it's able to penetrate through, and as you can see in the visual right here, that we can collect more usable and renderable data. However, this is not fair for the patient to be required to wear a certain hairstyle to get a diagnosis, and thicker hair, such as the one on the right, the very right visual, it's very, very difficult to cornrow. So even if we were able to get that, as you can see, the electrodes are still climbing onto the hair, so there is still a gap between the scalp and the electrode, and that still makes it difficult and can lead to future errors as well. So the necessary solutions that we need to currently imply is that patients should not be responsible for the misdiagnoses that are occurring, and it's the medicine fields or neuroscience research fields responsibility to create devices that are actually useful and able to penetrate to their scalp and deeper skin tones. So this would include changing the optodes for FNIRS, so using different light to capture darker skin tones more effectively, And then changing the electrodes and working with people who are very well equipped and understanding of coarse curly hair to create electrodes that penetrate through darker hair and thicker hair and coarse and curly hair even. And then the number one root that's causing all these problems in this never-ending cycle is to include demographics within the research, as it can lead to less blockages and issues within the neuroscience community, and we can understand how to better develop machines that are effective. Thank you.
Great work. All right. I have a really interesting question here. Do you think the shortcomings of the medical equipment you mentioned happened by design or by accident?
So basically, I think it happened by design because we do, as I was explaining in the beginning, we have a very strong, we have a really strong apparency for having a bias toward the Western demographic. So like all these examples, like the Tuskegee trial, the laser hair removal. Laser hair removal is modern time technology, and that still doesn't work for a lot of people. So we have a typical bias towards the Western demographic. So I think the machines that were created were mainly tested on the Western demographic. So I think, in a sense, it was sort of, I want to say purposeful, but I can understand how it was also an accident. But then again, if it was an accident, there's such a deep-rooted bias that if there was unusable data in the beginning hand, then why was it truncated out? Why was it not addressed before? So people with cerebral palsy or Parkinson's are being continuously misdiagnosed even till today, which is kind of like the issue that I'm trying to address with this.
Oh, great answer.
Thank you.
All right, good work.